Hello everybody and welcome back to the C programming tutorial series. Today in number 4, I think, we're going to be getting into logic and looping. So we're going to be talking about if statements and else if statements, and we're also going to be talking about for loops, or otherwise known as counter loops, and while loops, also known as conditional loops. So let's get right into it. First, we're going to start off with if statements. So we're going to be talking today about what makes a programming language a programming language. Think of HTML, for example. Some people call HTML a programming language, and they're what I like to call wrong, because HTML cannot make its own decisions. That is why it's not a programming language. It is code, but it's markup, right? It's being parsed to make a web page, but it can't actually make its own decisions and all that kind of stuff. It uses JavaScript for that. So yeah, this is what makes a programming language, is the fact that it can make decisions, it can follow logic. So we are going to be doing some logic in our programming language. Beautiful, right? So, most languages do it the same way as C. They use something called an if statement. There are a few that do it differently. I think it's called something else in Perl, I believe. I can't remember. It's been a long time since I've written Perl. But anyway, you have an if statement. So that is all you need to write for the syntax of it, and these little beautiful brackets to define that block. Inside of this parenthesis, you're going to have a condition. So let's go ahead and make a test condition now. We'll just make int age equals 10. Okay, the program is the computer is 10 years old. Okay, so in our first statement, let's make something that can determine adult privileges, okay? So if age is over 18, you can gamble, right? You might not be able to go to casinos. That might be 19, depending on where you live, but you can enter the lottery and stuff like that. If your age is over 16, you can drive. Otherwise, nothing. Okay, if you're under the age of 16, you're still considered a child. You can't really do either of these activities. So this is kind of my own little fun example of how to do an if statement. So, in the if right here, we're going to check if age is over the 18. Actually, it should be like that, right? The reason for that is this is a conditional error that sometimes people run into. If we just had it like this, right? If the person is 18, it will say that they cannot gamble because 18 is not bigger than 18. It's equivalent to 18. So this little block of code that we're going to write will not execute, and therefore it'll say that they can't really gamble, and that's not true because they are over the age of 18. They are 18. In real life terms. In programming language terms, this doesn't make any sense. Over 18, in terms of an integer, means 19 or above. Whereas in real life, if you just turned 18, you are over the age of 18, right? Yeah, it was a little bit confusing. Anyway, we are going to be printing something beautiful. We're going to print you are years old, so you can gamble. Right, and we're going to use the age. We're just doing some formatted printing. The %i indicates that we are going to be putting an integer in there, and then there's our integer age. All right, now we are going to make an else if age is greater than or equal to 16. I forgot to change it up here. Silly me. There we go. Above or equal to 18. And we're going to do the same right here. And we're going to print you are %i years old, so you can drive. Yay. We don't need another thing there. And then we're going to have an else statement finally. And you are %i years old. You are too young to gamble nor drive. Okay. And, oh, we almost forgot our age parameter there. Hold on. Let me just fix that real quick. Perfect. There we go. Now I want to talk about something. So the syntax is pretty simple, right? And then if you're just setting the condition, an else if is attached to this if statement. So if this case fails, it will fall back to this case. If this case fails, it'll fall back to this case. And this case will always be fallen back to. There's no point in the loop where one of these blocks will not be executed. So if this block checks out true, then that's fine. This block checks out true, and that's fine as well. Now, there's a problem here, and I'm wondering if you guys can spot it. I'll give you a few seconds to see if you can spot it. Okay, there's a few seconds. I don't know. You could have paused the video or something. I don't know. But anyways, the problem here is this else if. The problem with this is if the person is over the age of 18, it will print this, and then it will enter the return. It will just return and do nothing. But the problem is people who are over the age of 18 can still drive just because, well, they're still over the age of 16, right? So this case will only execute if the case is 16 or 17. If it's 18 or above, this case won't execute. So we're going to have to actually change that to an if statement. Now, this is kind of weird. This is kind of on its own. I'll just separate it with a new line just to show that's kind of its own case. And then right here, we have this work. Depending on the program you're writing, this might not work as well. For this, it will work fine, because if age is over the age of 18, it will execute this and this. If you are 17, it will only execute this. If you're 16, it'll only execute this, and if you're lower, it'll only execute this. But if certain cases, you might have a case not covered, and it could break your program, so it really depends on what you're wanting to do. This will work fine, though. So if we go ahead and set our age equal to 10, like we have it right now, and we go ahead and build using our handy-dandy make command, you are 10 years old, you are too young to gamble nor drive. That is correct. Now, if we change this over to 17, for example, and we make it again and run it again, so you can drive, but you cannot gamble, right? And then if we go ahead and make this 21, and we build it again, you are 21 years old, so you can gamble. You are 21 years old, so you can drive. I forgot to put a new line character in there. Yeah, I'll do that in loops and stuff. That is it for if statements. It's basic logic. Now, there is something else called a switch statement, which is good if you have a lot of different cases, especially for something like an age. You would probably want to use a switch statement. I'm not going to cover that in this tutorial because I don't want it to be absurdly long, so we're just going to go right on to loops. So there are two different kinds of loops. The first one we're going to cover is a for loop, or a counter loop. So it's written like that. It's for and then parentheses, and then we will put it in our little parameters or arguments or whatever in a second. So right here, so our first parameter. Actually, let me put in this here. This is an infinite loop right now, by the way. That's an infinite loop. So the semicolons right here don't represent terminators. They're actually separators. So your first your first little thing here before your first semicolon is where you're going to be setting the initial value for a variable. In between the semicolons is where you're going to have a condition, and then at the end is where you're going to be either incrementing or decrementing the variable. You can skip an argument. Okay, right now we're skipping an argument. This will go on forever. But I'm not going to go into that just yet. So let's make a for loop that counts to 10. So we have int I equals 0. So we are setting a variable, I equal to 0. You can define it in the loop, or you can define it outside of the loop. So what I'm saying by that is you can define int I right there and then just change it like that. It depends. Well, it doesn't depend. You can do it either way you want. It's really personal preference. Now we're going to get to the condition. We want to count to 10. So we could do this, so there's going to be a problem with that, but I'll show you that in a second. And then to increment I, we're just going to do I++. For those of you that don't know programming nomenclature, that is equivalent to plus equals 1. It's just kind of a shorthand because we're lazy. So what that's going to do is it's going to start I at 0. It's going to count until I is no longer lesser than 10, and then it will stop, right? It won't iterate anymore. So let me just print f, and we're going to say I equals that, and we're going to print I. And this time I'm actually going to put a new line character in there because it looks much nicer. So if we go ahead and run this, I'm going to show you guys something that does not work. I don't know why I closed my terminal. 1 second, let me just get that back for you. Now, the program runs fine, as you can see, but we wanted to count to 10, and most people every day, they start at 1 and they go through to 10. They don't go 0 to 9. Now, that's in mathematics and in programming. The problem here is we've set I equal to 0, and we're going until I is no longer lesser than 10, which is 9, right? Because if you got to 10, 10 is not lesser than 10, so it's not hitting the 10th case here, or the 11th case, actually. So yeah, we can fix this a few different ways. One that we can do is we can set I equal to 1 and loop it until I is equal to 11. Or if we wanted this to be more intuitive, we can make it lesser than or equal to 10, right? And if we go ahead and make that and hit T2, see, it'll start at 1 and it'll go to 10, like how most everyday people count. Or another way we could do this is we could leave it the way we had it before, and we could change this to make it I plus 1, right? So if I is equal to 0, it'll take 0 and add 1 to it, right? Just some logic there. And you might not get this, but you will get this as you continue programming. You will. That's one thing that's cool about programming. You build up such a great common sense. It's like logical thinking. When you program, it's great. You get really good at it. So as you can see, it does the same thing here, right? It does the exact same thing. It's just a different way we use to achieve it. So it's setting I equal to 0 and doing that. Now here is a problem. Let's assume we were using an array. We're not, because we haven't covered arrays yet, but let's assume we're using a theoretical array, and we want to store something at the first index. Okay, let me just change that back over to 0. You would not use array at 1 to access the first index, because that'll give you the second index. Almost all programming languages start at a 0 index, so that would be your first element at the 0th spot. Kind of sounds weird. It's the same thing here. We're starting it at 0. We could start this at a different number. We could start it at -1 as long as it's a signed integer, which it is. We could start this at -1 if we wanted to, but I just thought I'd point that out. And earlier we covered an off by 1 error, very common in programming. It happens to expert programmers as well. Off by 1 is so big, just because it can be unintuitive looking at this. You know what I mean? You see 0, you see 10, you're like, okay, it's going to go 0 to 10. But it's not. It's going to go 0 to 9 because of our condition. This is not lesser than or equal to, it's just lesser than, right? So be aware of off by 1 errors. Okay? Now we're going to cover a while loop. Now, a while loop, or also known as a conditional loop, goes like this. So you have the syntax just while, and then in the parentheses, you have the condition. What we wrote right here is a infinite loop, kind of like our first for loop was an infinite loop. This, while true, it's always going to check if true is equal to true, and true will always be equal to true, so it'll always run this loop, and you'll be stuck in an infinite loop, and if you don't have something to break out of it, that could be bad if that's not what you're going for. So in here we'll go our condition. So let's make our for loop from the last one, and we're going to implement it using a while loop instead. I shouldn't have. Hold on. I'm going to get back my for loop. Okay, and I'm just going to comment that out. Ooh. Okay, and we're going to make the while loop using the same thing. So we're going to set I equal to 0, and you know what? That's messy. Let's just set it to equal right when we create it. There we go. And then we're going to check while I is lower than 10. We're going to printf I equals, oh my god, I. Perfect. Although it's not. Because if we went ahead and run this, we'd be stuck in an infinite loop, because I will always be lower than 10, because it's 0. We're not modifying it, we're not adding to it like we did in the for loop. It'll just say I equals 0 millions and millions and millions and millions and millions of times, because we have not incremented I. So at the end of this, we're going to have to do I++. As you can see, our for loop and our while loop are extremely similar. A for loop is kind of like a while loop, except it's more complex. It allows you to start an initial value, check a condition, which is the same as the condition here, and increment it right inside the loop instead of having to do it, on your own kind of line here. It's a little bit confusing, but they are very similar. You can use both loops pretty much for any case. It's just dependent on how, certain ones are more suited. For example, for counting, you want to use a for loop, and for checking while a condition is true, you're going to use a while loop. Okay, that's kind of intuitive, but you can use either one for most situations. So there you go. There's a while loop. Now, let's say we wanted to do a break statement, and we wanted to break out of this early, right? I is equal to 10. Let's say if I is 5, which it will always hit, equals 5. I don't know what I was thinking there. Break. Okay, I don't need to put in curly braces here because it's only one line. So if we go ahead and run this, it will only count to 5. See how it goes right over to 5 and then it stops? That is because, and it prints out 5, it doesn't print out 4 and then stop. That's because I put the print statement before my break. This is called a break statement, and this is very commonly used in infinite loops. We can actually do that right now. Let's make this an infinite loop, and then check if I is equal to 5. Just put a little bit of space there, because it's a little bit unclean right now. So if we go ahead and make that... What? Hold on. Oh. It's like that, I think. My mistake. What? Ah, whatever. I forgot it's C, not C++. I'm just going to put while 1 equals 1. You could just put 1. That'll give you an infinite loop as well. I don't know what I was thinking there. Sorry, I've been doing a lot of C++ lately. Okay, so there you go. We have an infinite loop. This should loop infinitely while 1 equals 1. But because we have this break statement, when I hits 5, it will break out of this loop and return. I hope you guys enjoyed the tutorial. If you did, please leave a like below, comment any questions or comments you guys may have on the video, and subscribe, and I will see you guys in the next tutorial.